In this session, we will discuss about the procedure to calculate or to find the candidate keys. We look at some examples. Now over here we have a relation R wherein the attributes of the relations are A, B, C, D, E, F, G and H. Now here there is some set of FDs which are given to you, and based upon this FDs you are supposed to find which is the candidate key. Now the first thing what you require to do is design an edge diagram. Now the edge diagram will be designed based upon the FDs. Now the first FD says AB determines C. So we design an edge diagram here. AB determines the attribute C. The next FD says A determines DE. A determines D and E. The third attribute, B determines F. So B determines F. Next, F determines GH. F determines G and H. So once the edge diagram is done, now we are supposed to find those attributes which do not have an incoming edge. So H, there is an incoming edge. G, F, E, D and C are all having incoming edges, excluding these two attributes, that is A and B. Now these attributes are called as essential attributes. Now these two attributes A and B are called as essential attributes because A and B cannot be computed by any other attributes. Now what do I mean by that is, none of the other attributes are in a position to search for A and B or to compute A and B. So what we do is we make A and B as an essential part or our candidate key. So when we say a candidate key, in this case your candidate key will be AB or AB along with some other attributes will form the candidate key. So now the first step over here, once we have got the essential attributes, we will find the closure on the essential attributes. So the closure on AB will be AB, C, then A gives D, E, B gives F and F gives G, H. So now if you see, AB is a key which gives you the entire relation R. So we can say that AB is acting as a candidate key in this case. Now are there any chances that other than AB, is there any other attribute which is acting as a candidate key? So it is very obvious that AB is an essential part of the candidate key which will help you to find the relation. Now we can have some other combinations like A, B and C. We can find the closure on A, B and C. But if we get the relation R with A, B, C, then it means that AB is a subset of ABC. But when we talk about candidate keys is nothing but the minimal set of attributes. So now in this case, AB becomes a candidate key. We look at the next problem. Second example, we have a relation R with the attributes range from A to H with this set of FDs. Now in this case also we follow the same procedure. We design the edge diagram. So AB gives you C, AB gives you C, BD gives EH, B and D gives E and H, AD gives G, AD gives G and A determines H. A determines H. Now we are supposed to find those attributes which do not have any incoming edge. So basically we are trying to find the essential attributes. So in this case we have A, B and D which do not have any incoming edge. So in this case we have A, B, D which are the essential attributes. So A, B and D are our essential attributes. So what we do is now we calculate the closure on A, B, D. So when we calculate the closure on A, B, D, what we get is A, B, D. A, B gives you C, B, D gives you E, F, A, D gives G and A gives H. So basically if we look at the closure, it is giving us the entire relation R. So based on this, now we can conclude that ABD is the candidate key. You can obviously, it is very obvious that these three attributes are always required to form the candidate key. So you can always have some more attributes added to it, but then in that case it will become a super key and not a candidate key. So now in this case we have ABD which is acting as the candidate key. We see the next example. So there are only two FDs over here. Again we start with the edge diagram. So BC gives A, D and E and D gives B. So we are left with only C which is the essential attribute. So now what we do, this is a special case, we find the closure on C. So C becomes the essential attributes since it is not being computed by any other attribute. So C becomes our essential attributes and it becomes a part of the candidate key. So now first what we do is we find the closure on the attribute C. So the closure on attribute C is only C. So it is not giving us any relation. So obviously this cannot be our candidate key. So now what is the next option? Now the next option is we combine this essential attribute with the other attributes. So we have a combination of CA, CB, CD and CE. We find the closure on all this triggers. Okay, now the closure on CA is, it gives us CA and nothing else. The closure on CB is CB. So BC gives us A, D, E. Okay, so we get one relation here. Next, the closure on CD is C, D. D gives B, BC gives A, D and E. So this is also giving us the entire relation R. Finally calculating the closure on CE. So CE gives us CE and nothing more. So we observe that this is not giving us a relation, this is not giving us any relation. Only CB and CD is giving us the entire relation. So as of now we can conclude that CB and CD are your candidate keys. Are there any more candidate keys? You can have a combination of CB with A or CD with A, but in that case, even if this is giving you the relation or even this is giving you relation, then this will be acting as your super key and not your candidate key, because by definition we know when we talk about candidate keys, it is the minimum number of attributes which act as the candidate keys. So in this case, CB and CD are your candidate keys. We move on to the next problem. Similar type of problem. So again we start with the candidate, we start with the edge diagram. So AB gives you CD, AB gives you C and D, D gives you A, BC gives D and E, BC gives D and E. Now, finding the essential attributes. So A is having an incoming edge, B is not having incoming edge, C, D, E all are having incoming edge. So B becomes our essential attributes and it has to be the part of a candidate key. So B along with some other attributes will become a candidate key, or B itself will become a candidate key. So we'll get to know once we find the closure on it. So starting with the closure on the essential attribute, that is B. So B, when we calculate the closure, B gives us B. That's it. So B is not a candidate key, neither it is a super key. Next, we combine this essential attribute with the other attributes and we'll check whether we are getting the relation or not. So we combine B with A, find the closure on BA, B with C, find the closure. So basically we are going step by step, B with D and B with E. So calculating the closure on all this. So when we calculate the closure on BA, BA gives us BA, AB gives us CD, D gives us A, BC gives us. So here we are getting a relation R. BC. So BC gives us BC, BC gives us DE, D gives us A. So here also we get a relation. Next, BD gives us BD, D gives us A, AB gives us CD and BC gives us DE. So as of now, 3 candidate keys. Finally, on BE, BE gives us BE. That's it. So this is also not a candidate key. So once we have calculated the candidate keys, so what we have done over here is we have combined the essential attributes step by step with the other attributes, trying to find out whether we are getting the relations or not. So we saw that with BA, BC and BD we are getting the entire relation. So in this case, for sure, these 3 are acting as a candidate keys. You can still go ahead and combine BC, BA and BD with some other attributes like E over here, E over here and E over here. But in that case, BC, E, BAE, BDE will act as a super key and not a candidate key. So in this case, we have BA, BC and BD which is acting as a candidate key. So it is very important when you calculate the candidate key, it is very important that you know the definition of a super key and the definition of a candidate key. Now we move on to a special problem and try and find out what are the candidate keys over here. So if we have a relation R with the attributes W, X, Y, Z and FDs, Z gives W, Y determines X, Z, WX determines Y. So the first step, we design the edge diagram. So Z gives W, Y gives X and Z and WX gives Y. So now in this case, we have to find the essential attributes. So W is having an incoming edge, X is having an incoming edge, Y is also having an incoming edge and Z is also having an incoming edge. So now this is a pretty different scenario. So how do we proceed with this particular case? So we are left with only one option. We take one attribute at a time and find the closure on each attribute. So when we take a single attribute, so we have to calculate the closure on W, calculate the closure on X, calculate the closure on Y and the closure on Z. So the closure on W is W, closure on X is X, closure on Y is Y, X, Z, W. So we are getting a relation over here R, and the closure on Z is Z, W. So as of now, I can say that Y is a candidate key which is giving me the relation R. But the question over here is, are there any other candidate keys? Now what is the thing that you require to observe is, when you combine Y with the other attributes, obviously those attributes will act as the super key. So if you combine Y with Z, YZ will become a super key because it is not a minimal set of attributes. Okay. So what we can do is we can check for the other conditions. Now what are the other conditions? What are the other combinations? We can have combination of, or we can calculate the closure on WX. We can calculate the closure on XZ, and we can calculate the closure on WZ. So here in this case we are not considering Y, because when we consider Y, which is an essential, which is a candidate key as of now, when we combine Y with some other attributes, obviously it will become a super key and not a candidate key. So that is the reason Y is not considered in this particular case. So when we calculate the closure on WX, what do we get? The closure on WX will give you WXY, and Y gives XZ. So here we are getting a relation R. Calculating the closure on XZ, the closure on XZ is XZ, and Z gives W, X gives Y. So here also we are getting the relation R. Now calculating the closure on WZ, the closure on WZ is WZ, Z gives W, that's it. So this is not a candidate key. So now, as of now we have got Y, which is acting as a candidate key, WX is also a candidate key, and XZ is also a candidate key. So the minimal set of attributes in this case is Y, which is acting as a candidate key. But no doubt that WX is also a candidate key, and XZ is also acting as a candidate key in this case. So it depends upon the database administrator of which attributes would be picked up from the set of candidate keys, and which attribute which will be made as the primary key.